Good morning, everybody. Let's talk about the normal curve today. If you're in class, we just watched this video on Vsauce. Well, I guess it's an alternate channel, but it's called the Galton board. And just to kind of play it for you guys, you got a whole bunch of metal balls here. You're going to flip it upside down.
Because there are so many of them.
Whoa, it's pretty loud. Let's mute this guy. As they randomly bounce between these pegs, they're going to end up forming a curve. Now, this curve has the pre-marked kind of shape to it. And what's interesting about this curve is that pretty much every time, no matter how you do it, it's going to form the same curve. So here's another example. Fills up pretty much the same curve. It works basically the same way every time. There you go. Pretty fascinating. I could watch it happen over and over again. Very nice. Now, this curve itself is what we're talking about today. Okay, this curve that is shaped like a hill. Okay, it doesn't look that interesting. But in mathematics, this is a curve that is called the normal curve because that is how normally things work. So for example, I have a whole bunch of different tabs here. These are just random different things I could think of before class started. So the first one is SAT scores. And here's the distribution of SAT scores, right? And it is exactly what you thought it would be in this nice curve. Now, it's a little unfair because the SAT kind of does their scores like they strategically want it to look like this. So it's a little bit misleading in a way that the SAT scores are so perfectly in this shape. But you can see, the general idea is that if the average is 1,500, then most of the people get an average score. And so that's why it's piled up high on the averages. Not a whole lot of people getting perfect. And so it's pretty thin down here on the perfect. Not a whole lot of people doing this terrible, probably missing every question on purpose. So it's pretty empty over there as well. Got another one here. This is the goal difference for home versus away for soccer. You can see that the estimated goals versus away is in red and the actual is in blue, right? Pretty much, even though that they are just estimating with the red, it's almost right every single time. It is more likely that 0 would be the case, but if you have a 4 or 5 goal difference, then there you go. This is something you heard early on with the coronavirus, to flatten the curve, right? And this is the idea that if we don't do anything, everyone's going to get coronavirus at the same time. Okay, and we're going to have everyone sick right here, and we're going to have so many people sick. And the idea is even if we have the same amount of people sick, we can just spread it out over time. That way hospitals don't get overrun. Anyways, right, it's normal curves, okay? It's all the same stuff. This is just me literally searching like coronavirus data, okay? Here is the batting average of baseball players. Obviously, 300 is a good batting average over here, but not many people can do it. Most average is like 250, 240, and so most people have 240, normal curve. This is from a video game. This is like ratings, like a rating system that goes from 800 to 2600. And this is just how many people are rated. And guess what? Most of them average about 1400. So normal curve right there. That's in the 3v3 bracket. There's a 2v2 bracket. Same thing, right? So normal curve, the main idea is that it just happens automatically, okay? That no matter what, if you have a whole bunch of data and you have an average of the data, that most of the people are going to pile up on the average, and way above average is going to be pretty thin. Way below average is going to be pretty thin. And so you'll get this nice bell curve. So one thing that you might have heard, and you'll definitely hear it in college, it's not that big in high school, but you'll hear a teacher who says, oh, we're going to curve the test, or we're going to have a bell curve on the test. And what they mean by that is maybe the average score on the test is really low. Like the average score is a 40 or something, and the highest score is a 60. So what the teacher's saying is we'll move that 60 up to the 100. We'll move that 40, and we'll kind of reorganize the scores so that it fits in this model, because a test should fit in this model, right? When I give a test, you know, or if all the Algebra 2 kids take a test, probably most of them are scoring like an 85. There's definitely hundreds, there's definitely 70s, there's definitely 50s, but not nearly as many as there are like 85s. Now, of course, when I do pre-AP in a class like this, the scores are pretty high. So let's talk about it. Okay, it's really easy notes today. We got some data distribution. And basically, these would be unusual distributions of data, and this would be the normal distribution, okay? And it's literally called normal distribution, okay? If you Google normal distribution, this will come up. In the video about the Galton board, he does say, you know, that it is a normal distribution, right? So these are skewed by something. Okay, we imagine that there's some sort of thing that is affecting this data that is making it either negatively skewed or positively skewed. So, for example, my test grades teaching pre-AP Algebra 2 look like this, because I've started out with a whole bunch of really smart students, and the highest score you can get is 100. And so it's kind of getting stuck. Everyone's getting stuck at getting that 100. And so my test scores would probably look like this. And that's just because I teach pre-AP and you guys are really smart this year. So we have this normal distribution, and we say that it is a bell-shaped curve and now we're going to get hit with a couple different weird symbols, okay? It is, first of all, symmetrical, but it is defined by the mean, and we get a funky symbol here. Maybe I'll try to highlight this. And also the standard deviation, which has another funky symbol attached to it. Now, mean we've heard of before. The mean is the average. The mean is you add them all up and you divide it by how many terms you have. You know, the average of the test, the mean, we've all seen that. And so this symbol for mean is basically a lowercase u that also has like a long bar on the front of it, which is definitely a weird symbol. Sometimes you'll see it look more like a capital M with like a long front. Sometimes it'll look more like that. But the way we say this, or if you hear it, is it's written like moo, but you kind of say it like Mew, like the Pokemon Mew, Mewtwo. But technically it's called Mew, but it's kind of MU anyways. And then the standard deviation is a circle with a little hat on it. And we'll talk about both of these before. Now, when it comes to this, the area under the curve, so all of this area that's underneath the curve represents like how many people are there, okay? It represents the distribution within that curve. It represents, I'm trying to think of the best way to put this. The area under the curve represents like percentage. I guess that's the best way to put it. So like if we have a whole bunch of area here, that's kind of like having a higher percentage than having it over here. I don't know. That's not the best way to put it. But the really big idea is that if you have a total area, you would have 100. Okay, so if we go back to any of these little tabs that I have open, right? Obviously, this is 100% of the players playing this video game, with the middle being 1397, so the middle being right about here. And then the area under this curve represents players of the video game, right? The percentage of characters, like how many of them are right here, how many of them are right here, right? So on this particular one, I like it because it's a little interactive. You know, I can see that where 1400 is, I can see there's 10% of the players. And then where there's 1450, there's 6%. And then where there's 1500, there's 5%. And then when there's 1550, there's 4%. And then when there's 1650, there's 2.5%. And then 1.9. So we can see that it's going down. Now here's what we're going to need to learn today. Okay, so first of all, this curve is the normal curve, and this is like 90% of what you need to learn from the notes today. One of the things is that you need to recognize that in the middle is that mu, and in the middle is that symbol for mean. And so in the middle is the average. Right? I mean, that's the whole point. That's the whole point. That right in the middle, where things are average, that's where most of the people are going to be, because that's what makes it average. Okay? And then we have these standard deviations. Okay? Now, the way that these work, the easiest way for me to explain it to you is that mathematically, if you calculate this stuff out, it's going to take us, we're going to split this into basically 3 categories. Okay, category 1, category 2, category 3, and then the extra. Okay, you don't necessarily have to write this. Actually, I wouldn't write this. And in order to kind of split these up evenly, we use some mathematics, and we're not going to do this part, but automatically the calculator is going to put certain percentage of people within these categories. Okay, and so this all seems pretty strange. We've got 34.1. You definitely need to write this in your little thing here. We've got 13.6. We've got 2.2. And we've got 0.1. Now, what does that mean? Okay, what that means is the computer program, the calculator program, is able to split it up so that 34% of the people are going to be in this category here. And obviously, the further we get from the middle, the less popular it will be, because the farther we'll get from the average. Now, it's symmetrical, so same exact thing on the other side. 34.1, 13.6, 2.2, 0.1. And then when it comes to this information up here, it's a little tricky. If you fall within 1 standard deviation of the mean, that means that you're allowed to go 1 standard deviation in both directions. And that means that there is 68.2% of data within 1 standard deviation of the mean. In other words, about 70% of all the data is right in the middle, or very near to the middle, okay? And then we're going to take that and we're going to add in these next standard deviations, right? Because now we're allowed to go 2 to the left and we're allowed to go 2 to the right. And so now we need to do 13.6 plus 34.1 plus 34.1 plus 13.6. Now, another thing we could do if we want to do this in the opposite direction is we could start with 100 and we could subtract the parts that we don't have here. So anyways, that would be 4.4, 4.5, 4.6. And so if we subtract that, we should have 95. I really don't want to get this wrong. I don't have these numbers memorized. 95.4 should be. Let's calculate it. .1 plus 13.6 plus 34.1 plus 13.6. 95.4. Perfect. And then, of course, if we're going to add in these extra 2.2s, we're going to get to 99.8%. Now, this information is basically all that we need to learn today. We're just going to use this information to help us solve these other questions. As long as you can understand that in the middle is the average, that's where most of the stuff's going to be, and then it's going to slowly spread out over time. Or sorry, slowly spread apart as you get away from the average. That's pretty much it, okay? So number one, the weights of 50 football players are normally distributed. So all that this means is that we've got 50 kids and that it's going to make this shape. Okay, so basically, this stuff isn't really that important right now. Okay, what is important is that the average is 178 and that the standard deviation is 8 pounds. So what that means is that we're going to start with this mean of 178. So 178 is going to go in the middle because that's where the average is, or it's sometimes called the mean, or it could even be called this little mu shape that we just learned about. Okay, all of these things are happening right in the middle. Now, the standard deviation of 8 pounds, that means that each of these lines are basically going to be plus 8 pounds, plus 8 pounds, plus 8 pounds. That's how we're going to figure out that right here is where all the 186 weighted kids would be, because that would be 178 plus 8. And then right here would be 194. And right here would be 202. That standard deviation is telling us like how big these little gaps are, and it's symmetrical. So in the opposite direction, instead of adding the 8, we should be subtracting the 8. So it would be 170, and then it would be 162, and then it would be 154. Now, what I would recommend, especially as somebody who's just starting off doing this, is to write those percentages from right above into your little sections here. So, for example, 34.1, 13.6, 2.2, 0.1. And you don't have to do this, but this does two things for you. Number one, it makes it right there available for you. And number two, if you do this like 3 questions in a row, you're going to memorize the numbers. Okay, they're not that difficult to memorize. You just write them a couple times and all of a sudden you know what they are. So now we're going to answer some questions. Okay, what percentage of players weigh between 178 and 194? Okay, I'll just use a highlighter. So that means 178 is right here. 194 is right here. And so if we wanted to know how many players are in this area, we just add the 2 numbers of the 2 sections, right? We just add 34.1% and 13.6%. We add those up and we get our answer. So let's see here. It's pretty. I'll just do it like this. So 34.1 plus 13.6 would be 47.7. So we could write that in here. 47.7%. Okay, what is the probability that a player weighs at most 170? Now, I'll warn you, these questions they're almost as simple as just adding questions, because all the math that we've had to do for A is just add these 2 things together. There is a little bit of trickiness to it, however, where you need to make sure you're getting it right. So if 170 is right here, and they're saying that your player weighs at most 170, are they talking about all the kids that weigh more than 170 or all the kids that weigh less than 170? Less. Right. So you just need to be a little tricky. It's especially when you see like at most or at least. That's when I see even some pre-AP students mess it up. So we're talking about this whole section here, which means we need to add up all three of these little parts. Okay. We need the 0.01, the 2.2, and the 13.6. That would be this section here. And if we add those up, that would be 15.9%. Now, some teachers, I'll tell you right now in my class, I'm not really worried about this, but the first question has asked us for percent, and the second question has asked us for the probability. Now, technically, these are a little different, and the probability would be 0.159. It's basically like you take the percent and you move the decimal place to the left, because a probability of 1 would be guaranteed to happen, and a probability of 0 would be impossible. So what's the probability? It's a little unlikely. Okay, it's kind of low because most of the players are going to be closer to 178. Let's do a little purple question here. What is the ability, or what is the probability that a player weighs less than 162 or greater than 194? Okay, so that means we're going to need 162 less than. So we're going to need this portion, and we're also going to need greater than 194. This portion here, we just got to add them up. So it's going to be 2.2 and 01, 2.2 and 01. That's going to be 4.6%. But if you want to be picky and you want to say probability, the probability here would be 0.046. So a little tricky. Of course, you guys know when you have the percentages and it's only a single digit, you need that 0 there. You guys have done this a lot. And then the last question here, how many players weigh between 170 and 186? I'm sure you guys are starting to realize this is really not that tricky. Between 170, which would be right here, and 186, which would be right here. Okay, perfect. That's actually one of the numbers that we wrote up top, right? That would be 68.2%. Now, this one is different, though. Okay, this one is very particular because it hasn't asked us for percent. It hasn't asked us for probability at all. It's asked us specifically how many players weigh between 170. And so 68% is not answering their question at all. They're asking straight up, how many guys is it? Or girls. Maybe they got girls on the team. Now, that is when we're the very first time we're going to have to go back and we're going to, oh, not black. We're going to have to go back and look at this 50, okay? Because there's 50 total players. We're going to need 68.2% of 50 in order to get our answer, okay? Now, how can you calculate 68.2% of 50? One of the easiest ways to do it is to do 50 times the probability, so 0.682. That's probably the easiest way to do it. I'll go to Desmos. Pull up my bar here, 50 times 0.682, and I'm seeing that 34.1 of the kids is there. Now, there's always going to be the kid in class who's like, how could you have 0.1 football players? You're right. Some teachers will want you to just leave it as 34.1. Some teachers will want you to put like about 34 players. I'm not going to be so picky. But this is the entire thing for today. Okay, basically, can you make this chart? Can you remember these numbers? Okay, can you add up the percentages? let's do one more, and I'm going to go really fast here because I know this is probably so easy for a lot of you. A set of 120 test scores are normally distributed. Okay, that basically means nothing. With a mean of 82, so 82 goes in the middle. That's probably like honestly the hardest thing you have to learn today, that the average needs to go in the middle. Standard deviation of 5 means that we need to be adding 5. So that would be 87, 92, 97, 77, that would be 72, that would be 67. And then again, you don't have to do this, but I recommend that you write 34.1, 13.6, 2.2, not 0.1. You'll be surprised how fast you'll memorize these percentages if you write them down. So, what percentage of the scores is between 72 and 87? Okay, 72 is right here, 87 is right here. So what percentage is that? Well, you add all those things up. Maybe you need a calculator. That should be 34.1 plus 34.1 plus 13.6. Looks like 81.8. That's the answer. 81.8%. What is the probability that a score is greater than 77? Okay. 77's right here. Greater than that would be everything over here. And you'll start to get the hang of this. For example, for this question, I know that the entire right side is worth 50%. Because there's 50% of people on the right and 50% of people on the left. And so I just need to add 34.1 to 50% because that's the only part on the left side. So anyways, what I would get is 84.1%. But again, it's asking for probability, so just make sure that you understand that these are kind of the same thing. What is the probability that a score is less than 82 or greater than 92? Okay, less than 82 would be over here. That looks like 50%. Greater than 92 would be this. And so that's pretty easy to calculate. 50 plus 2.3 would be 52.3%. And then, of course, it's technically asking for probability. So maybe you want that. And then for the last question, about how many students scored outside 2 standard deviations of the mean. Okay, so this is going to require you to really understand kind of the lingo of what we're talking about today. Okay, the mean is in the middle. The standard deviations are the little jumps. Okay, so they're talking about not in the middle, not out one more. They're talking about only outside the middle 2. Okay, so what they want is they want this and this. Now, that we've already calculated that up here for this purple question. Outside of 2 standard deviations, that would be 4.6%. We've already calculated that. But again, they don't want percentages for this 4th question. They want how many students scored outside of it. So what we need to do is factor in this 120 total test scores. The easiest way to calculate this, in my mind, is to do the number multiplied by the probability, which would be 0.046. Make sure you put that little 0 in there to make sure that it is a 4.6% and not 46%. And so go to Desmos, 120 times 0.046. It should be pretty small, 5.5. And again, always going to be somebody who says 5.5 kids. What the heck? Yeah, you could say, maybe about 5 students. Right? Or maybe you want to round up because it's 5.5, so say about 6 students. I mean, when it comes to those rounding things, it's not that big of a deal. You'll figure when you see the answer, you'll know it's the answer. If the answer needs to be perfect, you'll see it specified up at the top where it says like, you know, don't round your answers or round your answers up to the nearest whole number or something like that. That's it. Okay, it's really not that tricky. Put the average in the middle and then go ahead and add your standard deviations. Remember those percentages and then just add it up. It's really not too bad. Hope this helps. This is a pretty simple intro to normal distribution, but that's how it goes.